Hey, it's Matt. We're back. So in this module, we're going to talk about loading data from an API that takes the form of a compressed CSV file and loading that to our local Postgres database. So we just discussed how to configure Postgres and what it means to run Postgres inside a Docker container on our machine. But now we're going to build a pipeline more advanced than our example that we discussed in the overview that pulls data, performs a light transformation, and then writes it to our data source. So we're going to start with a new batch pipeline. We'll actually rename this. We'll go edit pipeline settings and we'll write API to Postgres. That'll be our pipeline name. Save the settings. We can then edit the pipeline. We're going to create a new data loader. We can use an API template. We're going to tweak this a bit. So let's call it load API data. So we have our template here. What we're going to do looks a little different. So instead of, we'll still use the blank URL. That'll work for now. I'm going to paste this in. This will be available in the course as well, so don't worry too much about it. That makes sense. We don't need to use requests for loading CSV files, even compressed CSV files with pandas. So we can actually start fresh here. But what we do need to do is map data types. So this is kind of a best practice. I went through this data set before the course and mapped out the data type. So this is a yellow taxi data set that you might be familiar with from other parts of this course. But essentially declaring data types is something that can be really powerful in data engineering and specifically with pandas. So why declare these? Why let pandas know what to expect for the column types? Well, it drastically reduces the memory usage that pandas is going to incur by processing this data set. And when you have a data set like this, which is about 1,200,000 rows, it can make a huge difference in memory consumption. So I'm going to show you how to do this, like first column, vendor, ID. You haven't seen the data set yet. I have, but I'm just showing you what one might do. So for example, you might look at this in Jupyter Notebook, take a glance at the columns, infer the types, and then in your pipeline, once you know the types, build this into your pipeline. And that does a few things. Number one, there's an implicit assertion that if the data types change, your pipeline is going to fail. And that's actually a good thing, because if you're expecting one thing and you get another, you want to be notified. So definitely a best practice to declare types. That's what we're going to do here. Pandas has an int64 D type. So we're saying, hey, vendor ID, that's an integer. For the next one, passenger count. I've taken a look at this. I know that it's also an int64, and so forth. And so there are a bunch of other columns. I'm going to fill this in. I'll make this available to you during the course. It's kind of silly to just have you type the same thing I'm typing. So just trying to call out a best practice here. We'll be right back after we do that. Cool, we're back. So we have our data types filled out. Next, we're gonna return the CSV. So we're gonna return, because that's how we pass data frames between blocks and Mage. We're gonna return the pd.readCSV, which you're probably familiar with if you've used pandas before. And that's gonna come from our URL. Now, this is where things get interesting. It's a comma-separated CSV, comma-separated values file. So the separator is a comma. However, there's gzip compression. The cool thing is that pandas can actually handle that out of the box. So if we just specify compression gzip, pandas will be able to take care of it. Now we declared our data types, so what we can do is go dtype equals taxi dtypes. Now pandas knows what to expect for the data types. And one more thing, so there are two columns in here that I noticed, right, that I didn't declare. And those are, the name of them is tpep pickup date time, and then the other one is tpep drop off date time. So I don't know what tpep stands for. Maybe if I knew more about this data set, that would be clear. But I do know their date times. And one thing you can do to help pandas a bit is to provide it with date columns to parse. And so we're going to call this list parse dates. And if we declare that as using the argument parseDates, pandas will know that these are datetime columns, and it'll parse them to an appropriate timestamp automatically. Now for our output. So it's cool that in Mage you can do inline testing. We're just going to leave this as a test that output is not undefined, just to make sure we load things as we expect. And I'm going to run this. Now it might take a second because it is a pretty large data frame, but we'll see what we get back. And it should be a relatively clean data set. And then we'll do some processing. We'll do some processing on this data set. Cool. So first thing off the bat, you can see that the datetimes have been formatted properly, and we have everything as we'd expect. So next we're going to do some transformation, extract, transform, load, right? We'll start without a template, and we'll do like transform taxi data. Boom. So in our transformation, the first thing I'm going to call out is that there's this passenger count column, and some rides have 0 passengers. Now, it's probably not a very good taxi ride if no one's in the cab. So that seems like anomalous data, and that's what we want to remove. So in our transformation here, we're just going to drop those columns. So a simple way of doing that, well, actually, what we'll do is we'll throw a print statement, and we'll say it'll be an F string, so we can check how many rows exist pre-processing. So we're going to pre-process this and say, hey, how many rows with 0 passengers? And F strings just let you interpolate variables. So the way to do this is take our data frame and say passengers. It's a passenger count, I believe, is the name of the column. Passenger count. Data passenger count, and then we'll just do an is_in, and we can do is_in the list 0 to get us rows where the passenger count equals 0, and then just do a sum there. So that should print out how many rows. We can run that really quick. Oh, looks like we have an error. Unmatched paren. Okay, so let's see, data passenger count. You'll probably see this before I do. So we don't have string highlighting in there just yet, so it can be tough to see. Let's see what we did. Actually looks good to me. Drop the assertion here real quick. Maybe it's in the print statement somewhere else. Okay, so that's working. Maybe I missed something. We'll do we can just print that. Do something like this. If we run that cell, we got a pre-processing, and then for our actual processing, we'll return our data where data passenger count is greater than 0. And so that should do the same thing. One other thing we'll do is we can do some we can fix the column names aren't the best on this, right? Like, so that's going to clean our data set, and we're going to return the filtered data set. Beautiful. So we can see all of our passenger counts are greater than 0. And the other thing we can do is add an assertion. So why not? We'll add a test at test def test output, and you can have more than one assertion. Every function decorated with the test decorator is going to be passed the data frame and run tests. And we can assert that the output of the cell has a passenger count. Well, actually, we just use this right here. This function, we would want that to be equal to 0. And if otherwise, we'll say there are rides with 0 passengers. So we should get a test pass here. And we have our data frame, as we'd expect. Perfect. Last step is exporting the data. So we're going to use, we can use a Python data exporter, or we can use a SQL data exporter. In this case, we'll just use Python. We'll write to Postgres, taxi data to Postgres. So our schema name, we have to define it. We'll say NY taxi, yellow cab data. Config profile, we defined our config profile to be dev in the previous example, if you'll recall. And then we want to replace that data set if it exists. We don't want to append data if we accidentally ran this twice. That's kind of part of idempotency. If you're familiar with that concept, I'd say look into that if not. So we can run this. Oh. And it should take our data set from the last cell, open a connection, export the data to our schema, and then drop it in. And it's about 1.25 million rows. So it's not a tiny data set by any means. It might take a second. Done. And I guess if we wanted to check that that worked, we could do like a SQL. We'll do a SQL data loader just to show you. Show you one there. We'll do a SQL data loader. We'll select our Postgres connection. We'll use our dev profile, and we'll use raw SQL. So select star. Be careful with select stars in the future. From NY taxi, yellow taxi cab data. We'll just do from the table there. Oh, we'll type it out. NY taxi dot yellow cab data limit 10. See what we get. Beautiful. So we know the data is there. We know it's been written. This has been reading data from an API and writing to Postgres. The next things we'll talk about is how to take this and write it to something like Google Cloud Storage, so in a semi-structured or unstructured format. And then from there, we're going to talk about taking data that's in Google Cloud Storage and writing that to something like BigQuery, which is a OLAP database, also maintained by Google. So in this example, we kind of got insight into loading data, performing light transformations, and then writing it to a clean source. Awesome. Can't wait for the next one. I'll catch you guys there.